So one important thing to remember is bond polarity is only the sharing of electrons in a single bond. So that's just two electrons in this bond, or just two electrons in this bond, or the two electrons in this other bond. And bond polarity is done by calculating the electronegativity difference. So it's a calculation, and it's going to be different from the next idea, which is the molecule polarity. Molecule polarity, on the other hand, is the electrons in the entire molecule. So taking into account the distribution of the electrons in the entire molecule involves looking at those polar bonds which are drawn as dipole arrows. So if you have a dipole arrow, you can think of it as a pull or a push in that direction. This arrow is pushing to the right and up. Meanwhile, this arrow is to the pushing up and to the left. And these are pulls, you can say pulls or pushes, but this is an overall upward push from those two arrows. And the left and right could cancel out, but nothing cancels out for what's going upward here. And so what this means is that there is an overall uneven distribution of the bond polarity. And so that means you have a polar molecule. So this is because of that bent shape. If it were a linear shape, these two would not have an upward component. These two arrows would just cancel out left and right. So between the bent shape of the water molecule and having polar bonds, which can be drawn as dipole arrows, this has an overall upward pull. When you add those arrows together, it's going upward because there's no downward arrow against it. That means that this is a polar molecule when there's an overall uneven distribution of the dipole arrows. Okay, this is an example of another molecule that has a central atom and two bonds, but it's a linear shape. So these bonds are both polar bonds, and they could be drawn as dipole arrows. And those dipole arrows in this case, because of the linear shape, will cancel out. This left pull will pull against the right, kind of like a tug of war, and those will cancel out. So here, the linear shape with polar bonds will not have an overall pull. Those pulls will cancel out, and that results in a non-polar molecule when there's an even distribution of the dipole arrows.